Do you have the questions there, or I'll open it? We'll need the calculator. Did you find them? Yeah. You found them?
Yeah.
Okay. So let's have a look here. Right, what do I ask you to do in the first part? What's the first part?
Estimate the mass of Mars.
Mass of Mars.
Is very long.
Yeah. I give you lots of information in it. So, we'll do this together. Tell me what you think we can do to get the mass of Mars.
G squared or 4 pi squared.
Yeah, what's this called?
Keplers.
Keplers. Very good. Okay, we'll use that. So Kepler said T squared, what's it, 4 pi squared over G, yeah, or cubed? Yeah?
GM.
Oh, sorry, GM, of course. And we're looking for M, so we can say M equals 4 pi squared or cubed over GT squared. Okay. Now, do I tell you the time? I
One
do.
day on Mars is 24 hours and 40 minutes.
Yes. Now we have to figure out which information we need. It's this one we need, the orbit, 7.65 hours. It's the time to orbit, not the 1 day thing. Yeah. So it's 7.65. Well, that's on. Oh, sorry. No, I'm looking at the wrong one. We need the time for Mars to orbit. So that's 1 year. So how long is a year on Mars?
24 hours and 40 minutes.
No, that's a day.
Yeah, but from the day you can calculate it.
No, I'm sorry, I'm wrong again. Sorry, I'm not awake yet. We need to use the time it takes the moon to go around Mars. If we want the mass of Mars, we have to look at the time for the moon to orbit Mars. So the moon takes 7.65 hours. So it was 7.65 hours. Okay, and also what we need to know? The radius, yeah. Do we know that? One of the moons, called Phoebus, is observed as orbiting Mars at a distance 9380. That's the OR. Okay. So can you just give me the numbers as we type them in, please? 4 pi squared.
Like 9380 cubed.
6.67 times 10 to the power minus 11, multiply, and now, what's the 7.65 hours? There's 3,600 seconds in an hour. So the mass of Mars is this, 6.44 times 10 to the 23.
How fast is it? 4 plus moving from
So we clearly established it's not 9 o'clock that makes it difficult to be on time. It's simply just being the first class that makes it difficult to be on time. Would that be fair to say? Okay. B. What was it? The V, is it? Yeah. So we can go with V equals omega or?
we can go with V equals root A.
And that one too. How fast? But I think this one's a little easier because we know the omega is 2 pi over t. So the answer is 2 pi or over t. And we know both the or and the t. Yeah?
The T is 7.65.
Yeah. It's still we're still using the moon. 2 times pi times or, and what did you say the or was, Ms. Sharif?
93800.
And the time was 7.65, wasn't it?
Yeah.
2.14 kilometers per second. Yeah, let's see. Oh, here we go. Phoebus radius can change by 10%. What is the fastest and slowest? Okay, so we'll look at the fastest. Oops, not the fattest. Fastest. Okay, so we have V1 or 1 equals V2 or 2. And in this case, we'll say V2, we want it to be the fastest. So V2 equals V1 or 1 over or 2. So if we want to make V2 the fastest, we need to make V2 the biggest. So then we need to make or2 the smallest. So we want a situation when or2 is at its smallest, and the smallest or2 can be is 90% of or1, because in the question I said the radius can change by up to 10%. So if we just plug that in there, then that means the fastest it will go will be this, which will be 2.14 divided by 0.9, 2.38. That's the fastest it can go. Now, what about the slowest? V1 or 1 equals V2 or 2. So again, V2 equals V1 or 1 over or 2. So the slowest it will go is when the or 2 is biggest, and the biggest or 2 can be is 10% more than or 1. So it will be 1.1 times V1, which will be then I'm sorry, I think I did that upside down. Just wait 1 sec. I should have not 1.1 on the top. on the bottom, of course, V1 over 1.1. So that means V2 equals .94. So the slowest it will move is this much, and the fastest it will move is this much. And the fastest it will move is when the radius is 90% of what it is usually, and the slowest it will move is when the radius is 10% more of what it usually is. Because remember, as the radius gets smaller, the planet moves faster. Good density of Mars. That's just good old mass over volume. Now we know the mass and we can work out the volume. Mass over 4 over 3 pi r cubed. We had the mass earlier in the question of Mars. That's the volume of a sphere. No, don't look at him. You know this. You know this deep down in your heart. The volume of a sphere.
You said you were going to tell me the volume and the area of the sphere and cylinder.
No, I didn't tell you this. I said it's in the. I said for the exam, the only ones you need are the sphere. Yes. You might have been thinking about the math class. In semester 1's math class, you need the volume of all the shapes. But for physics, it's just the cylinder and the sphere that they do in the exam.
The volume and the area.
Yeah.
So what is the volume?
You can Google this. Volume of a sphere is 4 over 3 pi r cubed. Area of a sphere is 4 pi r squared. The volume of a cylinder is pi r squared h. And the area of a cylinder is 2 pi r h plus 2 pi r squared.
2 pi r h plus
2 pi r h plus 2 pi r squared. Faster than Google. Smarter than Google. True. Okay, continue. What did we say the mass of the sphere was? Of the Mars? 6.44 times 10 to the 24? 23. Over 4 over 3 pi r cubed, and the radius of the planet Mars is given in the question, I'm sure. Now that's the distance from the moon to the planet, but we want the radius of Mars is 3390. So 3,946 kilograms per meter cubed. 3946. Okay. What is the gravitational field strength on Mars? So that formula we have is G. Yeah. Yeah. Now I'm trying to think. Is there a square in it though? Are you sure? I think there is. Yeah, or squared. Yeah. Okay. So 390. Okay. What did we say the mass was? 6.44, wasn't it? 10 to 23. Wasn't that it? 6.44? And then the radius squared, which we said is 3390. What did we say the mass was, Ms. Sharif? 23. And the radius 3390000. Yeah, it's smaller than I expected. 3.74 newtons per kilogram. What is the altitude of the parking orbit for the probe around Mars? So if we put a satellite in a parking orbit around Mars, what is the distance, the altitude, the height? So we can use Kepler again, where we say t squared is 4 pi squared over gm or cubed, but here we're looking for or. So you get or equals gmt squared over 4 pi squared cube root. And we're talking about Mars here. So into our formula we go. Cube root 6.67 times 10 to the power of minus 11 times what was the mass? I keep forgetting. 6.44 times 10 to the power of 23 all over 4 pi squared. Is that right? GMT squared over 4 pi squared cube root. That's the radius. However, yeah.
Why is it different from the radius of the Mars?
Because this is a satellite around Mars. So why would it be the same? Because it's very high.
You are using the same formula. The first question, A.
Oh, I see what you mean, yeah.
Did you type the time?
I did not, thank you. Yes, I'm sorry. Where I didn't type the time in. I know what you're saying, why isn't it the same? The thing that's different in the formula is the time. Because when we first did it, I don't know, we were using like 7.65 hours, but this time we're using a parking orbit, which means 1 day. And on Mars, 1 day, 24 hours and 40 minutes. So that's 24 and 40 minutes is 2/3 of an hour, so 24.6666 times 3,600. Okay, that's better. That's how many meters, that's how many kilometers, but this is the distance from the center to the center, and we want the height, so I need to subtract the radius of Mars, which is 3390 to get the height, which 17082. Oh yeah, I changed this into km. Yeah. G. What is the gravitational field strength on the probe when it's in this orbit? Okay, so it's the same again, except the only difference here is we have a different radius. It's going to be much bigger. So we can recalculate. Fraction 6.67 times 10 to the power of minus 11 times 6.44 times 10 to the power of 23 over the radius squared, and the radius is 17082,000 plus 3390000. So this should be smaller than the answer we got earlier, and you can see it's much smaller. It's only 0.1. 0.102 newtons per kilogram. what is the total energy of the probe while it's in this parking orbit? Okay, so the total energy will be the kinetic energy plus the potential energy, which will be a half mv squared minus gmm over r squared. Thank you, r. And
minus.
You answered your own question. Yeah. Now, what do we know? We know G, we know the mass of the probe, it's 100 kilograms. We know the mass of Mars. We know the orbit. We know the mass of the probe. The only thing we don't know here is the V. So we need to change that. We can say, remember, V equals omega r. No, that was a different V, I think. That was the V for the moon, I think so. V equals 2 pi over T or 2 pi r over T. That's the V. Yeah? So I can change this into a half m 2 pi r over T squared, and remember T is 1 day here, minus gmm over r. So we'll put in all the numbers and see what we get carefully. A half m v squared, which is 2 pi, and the radius, we worked it out earlier, is 17082 plus 3390 and the time we said is 1 day, which is 24.6666 times 3600. Yeah, and then we have minus, okay, G, mass of the probe, mass of the planet Mars, which we said is 6.44 times 10 to the power of 23, over the radius again, which is 17082. Oh no, I'm out of space. I'll have to, I'll change this to 25 and get rid of these 2 zeros. And then if I do a minus 11 on it, I can get rid of all of that. So minus 11, so that would be 14. Okay. Let's see. 17082 plus. It might just about get it. Yeah, I will. Well, you might have to do it for me on your calculator. Wait, I think I can fit it in. Oh, no, so close. 17082 plus 339000.
2047.
Wait, 2047. 2. Like this? Okay. Now it's negative, and the reason it's negative is because it's trapped. It requires energy to be free, so we're expecting it to be negative. In megajoules, it's minus 105 megajoules. My battery's about to go, so I'll just plug it in. Hang on, it's here.
By the way.
Just plug it in.
Really? Thank you.
Which one? You got the Casio 991?
Yes, I know.
Just like your one? With the solar panel. Right. So now there's no excuse now for you not doing calculations in class.
Yeah, I should give you the old one.
As a memory, is it? Okay. Did you write that down?
Yeah.
Yeah. Okay. We'll have a look now at Theo's exam question here. Where's Let's see what the fields was like 2 years ago. That's the most recent paper I have. I want to try and do one that has to do with gravity, which we were just looking at here. Right, let's see. Oops. There's my... There we go. Let's have a look at this together. First one, gravitational field strength. That is the force per kilogram experienced by a mass in a gravitational field caused by a larger mass. You don't have to say it exactly like that, but basically it's a gravitational force per kilogram of a small mass inside a gravitational field of a larger mass. Determine the mass of the Earth if its radius is 6400. Okay. So what information do we have here about the Earth? We know its radius. We also know times. But is that enough? Yes, it is actually. And the little hint they're trying to give you is you should be looking at the gravitational field strength formula, because they're hinting you to do that because the first thing was asking you what it is. So I should take you 1 minute, now that you have your new calculator especially.
No, I was not talking.
It's too special, is it? Goodness. Alright, well then, can you still do it? Part 2 here, please.
The Kepler.
No, not the Kepler.
I have the diamond. Yeah.
But you don't have the orbit radius. The radius of the orbit from the Sun to the Earth. You only know how big the Earth is.
I still have to.
I told you the hint. Gravitational field strength formula. That's the hint.
Yeah, G equals G over R.
Yes, exactly.
I have the G and I have the R. I don't have the gravity.
Let's have a look here. This A part, is it A or 1? A part 1. Right, gravitational field strength. That is the force per kilogram on a small, what's often called test particle experienced exerted, what's the best technical word I can get? Exerted? Can we do better than exerted? I don't want to say felt. Yeah. Force per kilogram on a small test particle exerted on it by the gravitational field caused by a much larger mass. And how can we make this more academic? Rather than saying much larger mass nearby, what's a more academic word than nearby? No. Locally means nearby, close. You don't even have to write like this. And the units, I'm writing way too much, but I'm making sure I get my 2 marks. The unit is what exactly? Units are newtons per kilogram. And lastly, the formula. Yeah, G equals Gm over R squared.
If I was proposing
Not enough. Not enough.
can I just write one and then explain what every lesson is, and then write
I suppose, I suppose that could do as well, yeah. It's only 2 marks, so that should do it as well. I'm just making sure I get the full 2 marks. That's all. Because, there's no calculations. Part 2 now. So, I said we should use this formula. Do you see how to get it yet? No? M equals G R squared over G. We know the gravitational field strength for Earth. It's 9.81 newtons per kilogram. And we know the radius. It's given to us. What was the radius here? 6400.
What I mean if I want to use just the
Distance between the Earth and the Sun.
given
It is not given.
in the exam.
It's not. Where is it given?
It will be given in the
Oh, you're asking me, will it be given?
yeah.
Yes, if you need it, it will be given.
9.41.
I got 6.02 times 10 to the 24.
6400000.
Yep. That's weird, man. That's weird. I don't think I've typed in anything wrong there. No.
6400000.
What is the density of Earth? Density is mass over volume, which is mass over 4 over 3 pi r cubed. And I have the mass on my calculator already. So over, and that's not the word, not cylinder, sphere, 4 over 3 pi r cubed 5486 kilograms per meter cubed. 5486 kilograms per meter cubed. Next. Are you writing any of this down, Richard? I'm not doing it for fun.
You're going too fast.
No, I'm not. Am I going too fast? Oh.
Yeah, from the answer. Did you give me 1 minute to write?
Okay. I don't think you want to write down the definition because that's in your notes, but probably want to write this part down, yeah? Next part. What is the speed of the moon, our moon, if one orbit takes 27.3 days and the radius of the orbit is that? So we can go with V equals omega or, and omega is 2 pi over t. And they give us the info in the question. So the formula is 2 pi or over t.
But I need the radius for the moon.
They give it in the question. And the time they give as well. 27.3 days.
No, it isn't time.
Huh?
First day, the radius. First radius.
That's it up there. 3.84 times 10 to the 8. I think. The radius, yes. 1023. That's what I got. 1023. So that's 1.02 kilometer. Well, I'll just leave it as 1023 meters per second.
No, confusing. What is the radius?
Yeah.
If it's the radius and same planet or the distance between.
Yes, practice. You see, practice. A spacecraft is put in orbit around the moon, and the moon has this mass. What is the time taken for the spacecraft to complete one orbit when it's 95 kilometers above the moon's surface and the radius of the moon is this? Okay, so we're looking for time here. I think we can use Kepler. So this one, there's a ship going around the moon. So we have T squared equals 4 pi squared r cubed over gm. And so T is the square root of this. What's the m here? Very good. And the r? The distance between the moon and the spaceship. So if we just hit that in, and then we need to get the radius there, and then here, well, now are we given the mass of the moon? I think we are. 7.18 10 to the 22. And the radius, well, it's 95 kilometers above the moon, and the moon is this big, so that's 1740 plus 95 kilometers.
You already disclosed the age?
Yeah, correct.
What?
The distance between the moon and the spaceship is the radius of the moon plus the height of the spaceship from the moon. No?
But the radius already in the moon.
I know. That's where the radius usually is. There's the moon. There's the spaceship. They give us this radius. They give us this height. And we need to use this radius in the formula.
Yeah, he's saying why not from the surface? Why you are using r plus h? Why we just do h?
Because the formula wants or. Give the formula what it wants. This formula works. This radius is the distance from here to here. This isn't our opinion. This is what the formula wants. I don't understand. What's your question? If I said F equals ma, I don't say, why do I give it the m? Why can't I give it something else? You know, I don't have a choice. Is that what you're asking me? I'm not sure what you're asking me.
Yeah.
Okay. I don't know how to answer that. We have no choice. It's the distance from the center to the center. Which works out to be this many seconds. Rats. Can I go back? Yeah, this many seconds, which is, it's practically 2 hours. 2 hours is 7,200 is 2 hours. So it's nearly 2 hours.
Why are you?
I'm just taking away a 3,600 and taking away 3,600 again. It's 63 seconds short of being 2 hours, is what I'm just working out. So the time is 1 hour, 58 minutes, and 57 seconds. Yeah. Because it's 63 seconds short of being 2 hours. So I'll take away 63 seconds from 2 hours. Okay, so that's the time it takes for it to orbit. So you realise at this point, we're actually nearly finished the section B question, and we've only been doing it for 10 minutes. So I know I say this about all the questions. So I think this one was okay. But like you said, you don't like it because it's difficult to know what's the radius. Yes. Determine the distance from the centre of the moon to the point P. Now we did this one in class. When are the two forces balanced from the Earth and the moon? So we'll just do it really quick again, but it's 6 marks.
Yeah, because it's really hard.
Well, we'll see. There's the Earth, there's the moon, and they call this distance x, and we'll call this distance capital R. And so this distance here to here is R minus x. So the force from the Earth should equal the force from the moon. So I would say force from the Earth equals force from the moon here. So that's G mass of the Earth, mass of the rocket, over R minus x squared equals G mass of the moon. Hey, you're like 10 minutes early, dude. Just give me a couple of minutes and then we can finish on that end, okay? Right, what was I saying? G mass of the moon, mass of the rocket over x squared. Right, cancel, flip both sides. Or minus, I need to say cross multiply. So it'd be ME times x squared equals MM times or minus x squared. Square root everything? Square root, square root, square root, square root. So I have an x here and an x here. I should take that one to the left. So this one times x plus this one times x equals that times 4. So if I take the x out, scratch x, and then divide, root mass of the Earth plus root mass of the moon. Now I can work out the x. So let's just hit that in. On the top I have a root, and on the bottom I have a root plus a root, and we have the radius, which is the distance between the Earth and the moon. Was that given to us? I sure hope it was. The radius of the moon is given. Determine the speed of the moon. Yeah, 3.84 times 10 to the 8 was the distance here. We've worked out the mass of the moon and the Earth earlier, didn't we? Mass of the moon we worked out, or was given to us. Yeah, what was it? No, here it was 7.18 times 10 to the 22. Mass of the moon, which goes on the top. Sorry, what did I say was 7.18, thank you. Times 10 power 22, and that was in the bottom as well. 7.18? No, they don't, because they're adding, not multiplying. 7.18, yeah, and then finally, mass of the Earth, which we had to work out. 6.02, 1024. 6.02, 1024. Let's put this in kilometers. That seems a bit too big. No, I guess okay. 37,800 kilometers from the center of the moon. And do they want that? Yeah. Okay. So we get equals 37,800. Let's just have a quick check on the calculator to make sure everything was in order. That's there, that's there, that's there, that's there, and that's there. Looks like everything is in order here. Yeah. Oh wait, no. Was that 10 to the 8 meters or kilometers? Japers, I hope it was meters. Yeah, it was. Yeah, okay, good. 6 marks. So now we've completed a full section B question in like 12 minutes. I think that's the end of it. Yeah, that was the end of the exam actually. It was the last question on the exam. You don't like it still?
Yeah. I mean, losing 6 marks for that last one.
I mean, I know you don't like it, but compare that to how much you'd have to do in like other questions, you know, there's a lot more steps.
No, I don't have a problem with like the majority of it, working like whenever there's which point should this particular thing be if you want this to equal this. It's always hard to work out the equation to get to the point.
Yes, I suppose that is the key. Do you want to write this down, or well, you don't? Actually, we did this one in the homework a couple of days ago. Okay, we'll finish it there.